Hello and welcome to a new video. Yesterday I made a video about Vlang, but the problem was that I didn't set up the audio correctly, so it was not recording my audio. Well, it started well, but then I changed the sound to my headphones and then it messed up the whole thing. So basically yesterday's video was wasted. So there you go. But the good thing is that I have what I did for yesterday's video. Well, I think I can show it to you a bit of yesterday's video.
Hello and welcome to a
So
new video.
then
Yesterday
I
I
was,
made a video about Vlang,
is
but the
this?
problem was that I didn't set up the
Oh, this is the, this is this video, sorry. It's not.
Hello and welcome to this new video.
Oh, I deleted it,
Is
sorry. I
one
think I
the
deleted it. Trash maybe? Yeah, here it is. Okay, so I will restore. I don't know if I did it correctly. Yeah, I think it will work. So restore. No, this isn't. Well, is this the one? Yeah. So this is the one. So I just want
Hello and welcome to a new
to show you
that shall be 2 main.v that compiles the entire
the
hardware.
yesterday.
And so you take 0.4.
So yesterday I watched a video of the B creator, which is called, you know, a small presentation of B or whatever. I don't know if I don't think I will rewatch it today. So a small presentation of B features at IBM. You can go watch this if you want, right?
The way we express ourselves is more than just.
Let's. I'm having a new kind of testing new browser, so that's why I have ads. Okay. So this video basically goes through what B is, why B, it's simple, whatever, it's good. Simplicity is beautiful, as it says, and then it presents some features of B, like hot code reloading, some graphics, UI, C2B translation. It compiles itself like in 0.4 seconds. Yeah, BSH, which I think is an alternative to Bash, as you can see right here. Bweb demo, so you can go and watch this, right? So it's good. I mean, like, if you want to know about more things about B. So we're just gonna go through this really quickly, so I don't have to go. So it also demonstrates how Doom was built for in B, translated to B, I think. And here's some Doom play, gameplay, whatever. It was not, I mean, perfect, but it was kind of good. And yes, so here it says that it's very similar to Go, has some differences as well. It's much smaller runtime. I think, I don't remember how big was the simple hello world binary of Go, but it was like 10 times as big as the one in B. So yes, so here is something that's analogous to what I'm saying, which says a simple web server written in B is 65 kilobytes and 7 megabytes in Go, so that's like 100 times less, which is great. So it shows some UI. I said that it looks good. It doesn't feel that good, but it looks good. You have to test it by yourself, and you will have your own opinions about that. So we have some graphics as well, and graphics are nice. I think that Go for games is not bad, or graphics related applications not bad. So also web related things, which I'm not really interested in for now. Then that's web, and then what we have here, BSH, which is some tools, that some features. What I was saying yesterday was that what would be cool, I don't know, I'm not an expert in languages or something, but what would be cool would be to separate like the core, like to have a graphic that separates the core B functions that are the most stable and robust and tested, and like LTS versions of the language or parts of the language, and then since it has lots of features, to see which language, which like parts of the language are the nearest to be considered stable. So if I write an app today, I will likely lean towards using the parts of the language that are the most stable. Then, so yesterday's video was quite large, so if you can see where it is. So this is my video of yesterday. And so I was watching the video, as you can see right here. Let me lower the volume because it doesn't even have volume. That's the thing. It doesn't have volume because I messed up changing to my headphones. So yesterday I wrote, with the help of ChatGPT, a function to calculate prime numbers in B. As you can see right now, that's what I'm doing. Of course, it's no audio, as I told you. So basically, I was learning a bit more about B, like doing B things, which I will show you just next. But so yes, I was like understanding and tweaking and fighting with B, then trying to see how arrays work, and I didn't found it. Then I asked ChatGPT to help me, and it helped me, and it worked. Yeah, I basically was benchmarking 100 million, or should I say prime numbers up to the number 100 million. And I learned some things like, okay, so let me go now to the code itself to show it more didactically. So sorry, where it is. So here's the code you were watching in the video. And then there were some things that I learned yesterday. One of them being that I had a problem yesterday. And the problem was that I, as you know, I like to define these like functions to avoid writing println and instead just write ol, outline, and then output instead of just writing print. But then yesterday the main.v file was not being able to find this, so I figured I don't remember where I found it, but I think I found that if I use the pub, I think ChatGPT helped me with this. Use the pub modifier, then it's better accessed by the main.v file. So yeah. Yeah. In the previous videos, I did not need to add that. I don't know why. It's maybe some internal cache thing. I don't know. But well, this time I was required to do this, otherwise it would not find these functions. Okay, so that was one problem that I had yesterday. Then here we have some. I commented all these other the rest of the code to just avoid some mistakes, and here. So let's clean this a bit. So coroutines, we're not using coroutines for now. Time, we're not really using time, but you can comment that. So it says hello world, then it goes and find prime numbers up to 100 million, like in this function This is what it says. This is code I got from ChatGPT. Let's see if I can find what I did in ChatGPT. Yes, so here's what I did yesterday in ChatGPT. Well, I'm just doing like a compression of yesterday's video, which didn't work out. But so right in C, prime number finder that is fast. So here's a prime number finder that is fast. Initialize in an empty array with a specific size. So this is how you initialize an empty array. Then I had a mistake in which I oversaw something, and I put this in it to false, so it was not working because it was turning false with already everything is false. So have to make everything true, and then turn it false when it is not a prime, right? Something like that. I think that's how this thing works. And then it just prints. I'm printing the last prime number to avoid, in order to benchmark it better, to avoid printing everything. So I will be benchmarking the printing, which I don't want to, and printing is very slow, so I wouldn't be really benchmarking the language, but the printing of the language, which is not what I want. So right, so this is the C version, which I have already implemented this in C, so I can delete this now. So both are the same. Let me see if I can find primes.c. So this is the primes.c file. Oh, now that I think about this, I could have wrote this here, but instead I wrote it in Nano, which was not very efficient experience. So I don't know, how can I like format this? I don't know. It's not, because it doesn't support C, right? Probably that's the reason. Sorry for the background noise. Yeah. Okay, so yesterday I do keywords equivalent, which is memset in bool prime. So here you have to use 2 lines to allocate memory and then to set it to true. But here in V, I do all of this in one single line, which is great. Of course, the syntax is new, and I had to figure out how to declare a array of Boolean. So what you do is you say mute primes, and then the assigned operator in Vlang, and then you say array of bool. But let me check if I'm recording the audio. Hello, yes, apparently I am. Okay, so that's how you do it. And then if it's a prime, which it is, right? I don't know why this is. It will always be a prime here, or no? Am I correct? But I don't know. But okay, so the thing is that in the end, C was faster. Do you want to see it by yourself? Okay, so here you can see it actually. This is the benchmark, as you can see. So this is this one that I'm selecting here. So the first one is B, which was 5 seconds, right? And then C was 1.7 seconds. So C was faster. It's not a lot faster, but it was faster. Can I make B run faster? I don't know. Do you want to see it by yourself? Okay, let's do it. So basically what we do is time. So this is the Vlang thing. Of course, this computer is slow. So if you run the same program in your computer, it will probably be faster, because this computer is kind of old. I have a newer computer, but I prefer to use this one for benchmarking to see how it performs on older hardware. So time being, main, as you can see, it's running, and it's done. 5 seconds. That's the B implementation. Now we're gonna time the C one, which is called primes sub C. Okay, time primes C, and is done. 1.8 seconds, 1.7 seconds in user real, whatever. I don't even know what's real and what's user. Let's ask ChatGPT. When using, oh, sorry, there's some sort of restaurant on the side. I will close the door. I'll be back. Okay. Sorry. So when using time in Linux, it shows a time for user, real, and what's the other one? And sys. Please explain them. Okay. Let's see. Okay, when you use the time command in Linux, you'll often see three time metrics: real, user, and sys. Understand this can give you insight into your program's performance. Real time. This is known as wall clock time. It's the time elapsed between the invocation and the termination of the command. This includes time that your program was running, as well as the times it spent waiting for resources like I/O operations or CPU availability. User time. This is the amount of time the CPU spends in user mode executing your code. It doesn't include the system time spent on behalf of your process, such as I/O operations or system calls. Basically, this is the time spent on the computational aspects of your program. Okay, so user time is the time spent of the computational aspects of the program, which is 5.4, and here's 1.7. The difference here is like 130 milliseconds, and here it is 100. What's with 100? It's 52 milliseconds. Okay, so that says something as well. Okay, then system time. System time is the amount of time the CPU spends in the kernel mode executing system calls on behalf of your program. The system calls could be for various services provided by the OS, such as file manipulation, process control, or memory management. In essence, real time, total time from start to finish, including time spent waiting. User, time spent doing computations, and sys, time spent doing system level tasks. Here's a simplified analogy. You're cooking the real time. The time you spend actually chopping vegetables is your user time. The time your stove takes to heat up the ingredients or your oven takes to disassemble would be akin to sys time. Your cooking process has to wait for this to complete, but they are essential for your recipe. Understanding these metrics can help you pinpoint performance bottlenecks. For example, a high sys time could indicate that your program is making a lot of system calls, which might be optimized. A high real time but low user and sys time might indicate that your program is I/O bound rather than CPU bound. Would you like to delve deeper into any of these aspects? Okay, so yeah, okay. I didn't like the analogy that much, but okay, let's do. Real time is the time it takes from the time I click enter to the time it returns the report. So yeah. Then user time is the time doing computations, which is what we would expect. And then sys time is the time it spends to do system calls. So it's 25, milliseconds, and here 36 milliseconds. So it's not the big difference. It's 11 milliseconds difference, which is not that much, I would say. But again, I don't have lots of system calls, so yes. So having said that, is it fast? Is B fast enough? Is this fast enough? So, well, it is fast. It is not as fast as C. Remember that I'm doing 100 million operations. So that's a lot of operations, okay? And still is not that big of a difference, right? And also, you have to consider that B is very, very easier to write. For example, yesterday, while I was writing this, I got a segmentation fault. even though it's a very simple program. And I think the problem was that I don't remember, but the problem was that I was here. ChatGPT told me to use size of this when this was declared as an array, but I don't know what happened, but then I changed it to malloc and then changed to n+1, right? And then it worked. The seg fault went away. So yeah. So this is, let's do another example. Okay, that's 100 million. Now let's do it half of 100 million, which is 50 million, of course. So 50 million. Okay. Now we're gonna run this to see if it works. Yes, so it's there. It's doing some calculations, right? It's done. So that's 50 million, but now I want to run it in time mode, right? So let's see how much it takes for 50 million. It takes the same as 100 million. How can that be possible? What? I mean, I'm sorry, this is not correct. I'm sorry, I changed the C file. I have to change the B file. So, sorry, my mistake. So, 50 million. This should be faster, right? Okay. Let's see how much time it takes to run 50 million primes up to 50 million. Okay. So it took roughly half, a bit less than half, which is great. Now we will see how much C takes. So for these, yesterday I used Clang. So Clang, it's compiled, and then we're gonna do a C, and it's again half of what it took previously, right? So maybe you want to compare these two again. 0.8 seconds and then 2.6 seconds. Well, the largest difference is, well, here in user, if we want to be precise. User, so computationally speaking, we have 2.6 seconds and here 0.8 seconds. Maybe because I'm not very good at B. Maybe there's something else that can be done. Maybe Clang is better optimizing than the B compiler. Maybe not. Maybe that's the speed of B. I don't know. But let's just think through and see if we can make it faster. Because, well, it's doing the same thing, right? It's doing the same thing. So let's see if we can do make B faster. So mute primes bool lang n+1 init true. Okay. Well, I don't know what else can I do there, right? Here in the for loop, it goes up to p times p, starting at 2, increasing by 1, and then checks if primes p. So correct me if I'm wrong, but wouldn't it always be true this? Because I'm initializing everything to true? Oh no, it will not. Because this is an inner loop. And some of them will be false. And in the next one, this could be false because it was, changed by this I, which transposes this. I don't even understand that well, but yeah. So, yes, I think it's hard to do something here. I mean, and also here, it's again. But we can optimize both programs, right? To make both faster and see. So, for example, well, because this prints all the primes, right? But I just want to print the last prime, and it is going. Well, it's not really doing that much because it's starting from the end, right? So, so, so yeah. So I don't think it can be optimized that much. I mean, of course you can get like half a millisecond less. I don't know, but maybe 2 or 3 milliseconds less. But that's not what we are looking for. So yeah. So maybe the other thing that remains to be done is compiling B in a different way. So I don't have B installed in path because if I do B, it says command not found. So I will install B in path. So how to add my B installation to path in Linux. Temporary. I don't like temporary editions. I want permanent editions. But I think it has to do with some bash RC or something. Bash RC. No, nano bash RC. I don't think I needed to do, but okay. So here we have some things that we may want to add to path. Basher C, path to B. Okay. Path to B. So what's the path to B? Let's see if I can find it. It's in apps B. So that's the path to B. Okay, so copy. Then Alexarm. Oh, it's not there. It's where it is here. Path to B. Home coder apps B. Okay. IntelliJ, please fix your terminal. Okay. Now, if I say B, it's there. That's amazing. Okay, so to compile something, I want to compile B, main.v, right? So I say B, main.v, I think. Oops, sorry, main.v. Oh. Unknown function OL. Okay. So probably need also to include u.v. Is that correct? Too many targets. Okay, so I will ask ChatGPT how to do this. How to compile B files, like multiple B files that depend on each other. Let's see. In B, we have multiple files, and they're dependent. We can place them in set directory and compile main.v file that contains main function automatically compiles all the B files. But that's not true. I mean, that's not true, right? Because as a module main, right? And here u.b says module main, and it's in the same path than this, right? But then it's not doing what it should be doing. Because if I mean, again, B main.b, it shows errors unknown function OL. So like what? I'm included. I mean, it's on the same directory, right? So that's a problem. It is not detecting the functions on the other non-main B file. I don't know why this is not working. I don't know. Okay. Don't know. But well, it says module main, module main.v, Bob, fun grid, fun main, grid LAN, B main.b, physical positive workers, positive current power, some unexpected issue. That's because you may want to consult the B language documentation of the community for further help. Check to more about this one and anything else. Okay. Let's do the simple thing, right? Because I'm with you guys. I don't want to spend that much time here. So the simple thing would be to copy this, well, at least this one, here, right? Okay. So let's try again. Now it's done. And then we're gonna do like time. Do you hear that? Main. And it's taking the same as when compiled by IntelliJ, I think so, right? 2.6 seconds, and IntelliJ, how much did it take? 2.6 seconds. So it's the same. I'm getting nothing for compiling, like you're just using the compiler. But, well, yes, is there a way of using optimization flags on the B compiler for better performance? Let's see. Prod. B prod main.b. Okay. Okay, we will test this. So we start with the prod. Production, right? Prod flag. Prod. So it takes a bit more. So probably it's doing something interesting there. So let's now time this thing again. Oh my god. Now we're talking. 0.566. Okay? But let's also compile C with optimization flags. Right? How do we do that? O3, right? Let's see, I guess. Okay, so time prime C. Oh wow, here you can see these two guys. This is now different, and this is now interesting, very interesting, because they're neck and neck. And even the B1 is faster than the C1. Well, I'm glad I asked ChatGPT for this. Okay, using the B compiler. Just adding the production flag, this prod flag, then suddenly B is faster than C. At least as fast. which is great. Yeah. So I'm impressed. I have to tell you, I'm impressed with this. And does it make sense to add that? Of course. Well, now I have to say that for language, what I was saying, the core language features, which is like running things, doing loops, calculating things, B is fast. But I don't know why I think it's a trade-off of compilation time and optimization, right? So you want fast compilation, then don't use proc because you're doing iterations on the code and so on. But then when you have are done, you use prod, and then it works. Similar to this. Of course, I don't really know what it's doing behind the scenes. Maybe it optimized too much, right? Optimized too much of it. It's being cleverly not doing some of the work it should be doing, right? That may be the case. So, but still, it's great. So, well, that's great. I like B because I like performance. It's a great language. And then, what else can I test just to see if to print another value maybe? I don't know. For example, I should not be doing. I'm not doing the right thing here, right? This is not what it's supposed to be doing. It's supposed to be doing primes at P, right? To print the actual prime number. Then what we also do is we're gonna do is primes at P divided by 2. Okay, and we'll do the same in the C one. And here is prime at P. Alright, and then prime at P divided by 2. Okay, it's saving. I hope it's saved. Okay, so now I'm gonna do the prod thing again. 1, 2, 3, 4, 5, 6, 7, 8. Well, I'm counting too fast, but probably at least 5 or 6 seconds. It's not that fast when it's compiling for optimization. So probably this. Let's see how long it takes. Before doing that, let's compile the C version. Okay. Well, C compiles a lot faster and went in for optimization. I have to give that to C, right? But okay, so yes. So let's time both. Primes first. Okay, let's time C. So this is the C version, which prints 1 and 0. I don't know why that is. Oh, yeah. I'm wrong again. This means is prime, and this means it's not prime. Okay. And now we're gonna time main. Again, about the same. Even B even faster than C. True, false, 1, 0. Right? So this is different. Okay. I like more the syntax of B, I have to say. It's easier to write, and it's a really good competition to the newer languages, right? Well, yes. So, yeah. There it is. B is fast. So this actually inspires me to keep doing some B content and to keep using B. I think B has a usage, is a legit language. It works, at least in the things that I'm testing it right now. The things that the problem that I still don't know, tell me if you know how to solve it, is why it's not included in my other files, like the u.b file. I don't know why that is. Please help me with that. Maybe it's been confused with other files that I have here. Well, I don't know, but well, let me know. Let me know. So I think this will be it for now. It is already 40 minutes, so thank you for watching. I hope you enjoyed. Give it a like, subscribe, or whatever you do on YouTube. Thanks. Bye. See you on the next one.